Hey class, welcome to part 2 of Unit G, which is taking a look at constructing tables. I think in my first video I ended by saying that we'd be looking at constructing graphs. We'll talk about that later. First I want to look at constructing tables. So this will be pages G3 to I think it's about G7. So suppose we've got the following problem here. We've got a simple listing of ages of the thousands of people in Red Deer. That's referred to as ungrouped data. So let's say they're all in one column of a spreadsheet. The problem is that it's hard to kind of get your mind around that to get a good feel for that. And so what we do instead is we put the data into tables. Now, that's actually what you saw back in Unit I. Remember in Unit I where we were looking at the different years of data? Here, let me very quickly take us back there. So I think it's about page, I want to say about 4 or so. No, not quite. Here we go. So here's the age distribution of in Red Deer in 2016. And you can see that they're put into classes. So this is an age class here. And of course, each of the other ones. And these are the frequencies. And we'll get to that terminology a little bit later here. This, incidentally, is going to be called the relative frequency. So we'll get to that later. Here's another example that we looked at. And here's another example that we looked at. Now, this last one down here is just really a graph. This one in 86 is kind of both, because you've got the actual numbers here, the frequencies. And you've got the classes, but you've also got a graph over top of it. Let me go back now to the page that we're on. So we're talking about constructing those tables, putting people into particular classes so we can get a better handle on it, a better idea. The construction of the data tables is a 3-part process. We come up with the optimal number of classes, and then we come up with the boundaries for each class, and then the actual counts, or the class frequencies. Now, I'm hoping that you take a look at much of this stuff and say, hey, this is easy peasy. I mean, we first did this stuff in like grade 1 or grade 2. And that's true. You've actually been constructing tables and putting things into classes since probably your first grade in school. But we're going to add a bit of a step here, called Sturge's method for determining the optimal number of classes. And it's a good thing to come up also with some symbols and terminology that we'll be using. So it should be an easy unit for you, but it's an important unit in terms of just getting some of the basics down here. So the first thing that we're going to do is we're going to talk about determining the number and sizes of classes. This data set here, which you'll also find at the end of the unit, but it's the ages of people in a group. So let's say they're ages of 50 people. I don't know what group it is. Maybe it's a huge family or something like that. And so they run from 14 up to 97. You can see these ones are actually all in order. You don't have to worry about them being sorted in any way. So suppose I want to put them into some sort of table that makes it easier to understand the distribution of the ages. Well, there's some different ways that we could do that. 2 common ways is the intuitive approach. The intuitive approach is where you probably have a good feel for ages, and so it's an easy thing to put them into classes. Now, take a look at some possibilities here. Suppose I decide that I want to have 50 classes or groupings of 1 to 2 years each. So the first one would be how many people are age 0 or 1. And then the next one would be how many people are aged 2 or 3, and so on like that. So I'd end up with 50 of these classes. Now, intuitively, that's kind of goofy because there's only 50 numbers to begin with, and there's going to be a lot of classes that are just 0, and you're not going to end up with any better feel for the number, really, than if you were to just look at the data sorted the way it is. So we can scratch that one and say, yeah, it's probably not going to be good. Intuitively, it just doesn't work. What about 20 classes of 5 years apiece? Now, that's actually the way that they did it in a couple of the age graphs in Unit I. So in the 2008 and also the 2016 one, that's what we did. But we were dealing with 100,000 people there. And so it makes sense to take a look at how many hundreds or thousands of people even fall in each of these different age groups, 0 to 4, 5 to 9, 10 to 14, and so on all the way up to 65 plus. But when you're talking about just 50 numbers, distributing them among 20 classes, again, you might look at that and say, not enough numbers, really. So we'd probably look at that and say, too many classes, that doesn't really work. Now, when we take a look at C here, this is 14 classes of 7 years each. And so you'd have 0 to 6 and 7 to 13 and 14 to 20 and so on like that. The problem with that is that you've got a lesser number of classes, which is good, but people don't tend to think in terms of sevens, right? People tend to like to be in classes of fives or tens or hundreds or thousands, things like that. So 7 is kind of a goofy number unless there's some reason for you to have sevens. People don't tend to think in terms of classes of 7. So we look at that and say, probably still a few too many classes at 14, and 7's kind of goofy, so we're going to scratch that. 10 classes of 10 years each. In other words, we're talking about how many people are in the 0 to 10-year-old range. How many are in the 10 to 19? How many are in the 20s? How many in their 30s? How many are in their 40s? And we look at that and say, yeah, that's probably the way I would do it. And so intuitively, that's probably the best way of taking the 50 numbers and put them in. We tend to think in base 10. And so that's an easy way of looking at it. This one could work, which is 5 classes of 20 each. The problem is that when you're getting into 5 classes, then you start to lose some of the information, right? The more classes that you have, the less information you have about the actual numbers. And so we could look at classes of, say, 15 or 20 years each, and that is something which is probably second best. It's not as good as 10 classes of 10 years. The last one here, so this one I would say, well, maybe, but I think D is still probably better. 8 classes of differing width. Now, that's actually what we used in the 1986 one, where we were looking at different times of a person's life. So the 0 to 4-year-olds were the preschoolers, and then the 5 to the, 9-year-olds, I think? Yeah, they were the primary age kids, and so on like this. And then later, you had your later young adults and the young families and the more established families, the seniors, and so on like that. And so that makes sense from a marketing point of view, not so much from a statistical point of view. So that can work depending on what the data is. So again, and we kind of look and say, well, it really depends. But for our particular data, we would typically go with this kind of thing here, which is 10 classes of 10 years. So when you're looking at data like ages or, say, marks in an exam, then intuitively, we tend to think in base 10, and that's what we would do. Makes sense. But what happens if you don't have a good feel for the data? So the example that I used before was, in another video, was suppose we've got 10,000 light bulbs, and each number represents their lifespan. I don't know how many hours each light bulb lasts. It depends on the type of light bulb, right? Is it dozens of hours, hundreds, thousands of hours, and what kind of range do you have, and so on. And if I got 10,000 numbers and they're not sorted in any sort of way, it's hard to really get a good feel for the numbers. So this is where we can use something called Sturge's method. And Sturge's method is a method to figure out, well, what's the optimal number of classes and the optimal class width for each one. And it uses a fairly simple formula here. 1 plus 3.33 times the log in base 10 of n, where n is the number of the data points in the data set. So here's some examples of what n is. And then we're going to do some calculations here. The optimal class width is found by taking the range, which is the highest minus the lowest value, and then what we'll do is we'll actually divide that by the optimal number of classes that we determined up there. So let's take a look at an example here. So using both Sturge's method and the intuitive method to determine the optimal number of size of the classes for the following data, representing the lifetime in hours of 60-watt incandescent light bulbs. Oof, that looks like quite the thing here. So we take a look at that and we say, well, the optimal number of classes is found by this formula right here. So we just got to figure out what n is. And so we count these up. We got 1, 2, 3, 4, 5, 6, 7, 8. It looks like times 3 is 24. So we've got an n equal to 24. And so now I'm just going to go back here, and the log of 24 is 1.38. All right. Now, you should see, check your calculator. By the way, you might ask the question, well, what kind of calculator can I use in this class? And the answer is, well, pretty much everything, as long as it's got a square root button on it, and a add, subtract, multiply, and divide. But you'll probably use something like a TI-84 from high school, or you might use something like a BA Analyst 2 or something like that. But you're not restricted to those by any means. It's just that those are the ones that you're most likely to have from high school or because of other classes. But take a look and see if there's a log button. It's often shown as a log 10 button, something like that. And then you can just put in the number 24 and you should get 1.38. All right, now let's take a look at the rest of this. Remember multiplication. By the way, this star here means times, and the star or asterisk is used in Excel to mean times, multiplication. So you do the multiplication before the addition. So it'll be 3.33 times 1.38 is that, 4.59, plus 1 is 5.593. One thing that I suggest is that don't round this number here if it's going to be used in another calculation. So we'll still need that for the next calculation here, which is the optimal class width. And the optimal class width is the highest minus the lowest. So now these aren't in any order here, but here's your highest is 1260, this guy right here. And your lowest is right beside it, actually, 672. And so if we were to sort those would be the highest and lowest. We take the difference between those two to get the range, and then divide through by the optimal number of classes, and we get a class width of 105.09. So what this tells us then is that we should have about 6 classes, 5.9, classes of 105. Now, this is where we would make some intuitive adjustments here, is we would say, we don't tend to think in terms of widths of 105, so we're going to change this into class widths of 100. So we'll probably have about 6 classes. There might be less and so on like that. Could be a little more, but it should be around 6 classes of widths 100. So we could make, it looks like 7 classes here, And we would probably not start at 672. We'd probably do the 600s and then the 700s, the 800s, and so on all the way up to the 1200s. So there'd be 7 classes. And then we could just count how many are in each one. And that's how you do that. Okay. I am going to stop this right here. And then in the next one, we're going to work through some examples. In fact, for homework, why don't you work through all these next class examples here. And so that'll take us to the end of G8. I think this is enough for one day.